So let's start with this here. Now you don't have to draw this just yet, right? But I just kind of wanted to talk about this note here, and you could probably write down this note, right? So just say done it when you finish writing this note, right? But essentially, we have the Cartesian plane, and the Cartesian plane is basically when we have this y and this x axis here, right? So they're both number lines, yeah? So you can see they're both number lines, yeah? And on these number lines, the number lines form a grid. So the Cartesian plane is just a grid, and it's consisting of x and a y axis. So the y is the vertical one, and the x is the horizontal one, yeah? And we can see here that once we have this x and y axis, it forms a two-dimensional plane. So it forms basically like a piece of paper that we could put points on. And those points, we call those points coordinates, right? So the coordinates, these are points on the grid, and they're given by numbers, right? And so we could write coordinates like this, where we write the x value first and the y value after, right? So we'll see how it works just now. But I just wanted to show you, this is an idea of one type of Cartesian plane where I have the x-axis in the middle, and the y-axis in the middle, and then the x-axis horizontally in the middle. And you can see that they both start with 0 at the center here. Now I wanna make a point here, and the point that I wanna make is that when I'm labeling, you see how I use 1 square to represent 1 on the x-axis, 1 square to represent 1. Well, I want to use 1 square to represent 1 on the y-axis as well. So you want to use the same ratio on both axes, yeah, so that you'll get a fair accurate thing, yeah. So you can see I have some points here. Now another way I could draw my axes, if you look at it, I have the 0 point here, and you can see that on the x line I have the positive numbers in this direction, and I have the negative numbers in this direction, yeah. So negative x values would be somewhere on this side, positive x values would be somewhere on this side, right? And then from the 0 you can see that I have the y value positive going up and the y value negative going down. So you can imagine that positive y points would be up and negative y would be down, right? So remember, we write the x value first. So let's just say we want to know what this point is. Well, we watch the x value first. So that point is lined up with 1 on the x. So we'll put that point 1, open brackets, 1, comma, and then it lined up with 2 on the y, so we'll put 2, and that is the point 1, 2, where we have 1 on the x and 2 on the y, right? So I'll just do another example here. Let's see if we could make out all of these points here, right? So so Scotia, what is this point here?
2, 5.
Nice. And Shazay, where's this point here?
5, 8.
Yes, 5, 8. Very good. So I think that you guys have a good, reasonable knowledge as to what's going on. Yeah. So we have here the point. This is the point 7, 4. Nice. Now you'll notice something, and a way to notice, all of these numbers are positive, aren't they? All of the x's are positive and all of the y's are positive. So when you have x and y's being positive, we'll end up in this quadrant of the graph where x and y's are positive. But if we come over here now, right, we could see that the x's are positive but the y's are negative. So you can expect all of these to have negative y values, right? So 7, negative 2. I write the x value first, which is 7, and the y value, which is -2. Over here I have 5, -6, and this happens to be on the same. This is 2, -6. And well, of course, this one at the bottom here is 4 on the x and -8 on the y. So of course on this side now you can see that these points here will have a positive y value, but they'll have a negative x value. So you can see here that this is going to be -6, 4. This one here is going to be -2 on the x and then 4 on the y. So you can see both of these are at the same level vertically. So therefore they have the same y value, and that is something that that we will take a look at later. So this here is, anybody want to tell me what this is real quick? Nice and simple, right? And of course, the points in this quadrant here will have all negative x's and all negative y's. So this is -4, -2. This is -3 on the x, -6 on the y. So you see the -3 on the x there and -6 on the y. And this one here is -6 on the x and -4 on the y. Right? So this is just the Cartesian plane, which is a Cartesian plane is formed when you join two axes, an x-axis for horizontal and a y-axis for vertical. And this forms a two-dimensional grid. And we can now make points on the grid called coordinates. And we write these points x, y. So did you guys write this?
Yes, sir.
Okay.
Yes, sir.
All right, nice. So first up, now I want you to look at this Cartesian plane here. You see how it's a little bit different. So it goes to show that when you draw in your Cartesian plane, you don't necessarily have to do it like this. Yeah, if you expect that, hey, maybe I'll be dealing with a lot of negative numbers, well then you could draw this one. But if you expect that, hey, maybe this looks all positive, so I might be able to just survive this using positive numbers, right? Then you could draw it like this. Notice where the 0 is. So the both axis positive starts at the 0, right? So really and truly the origin, and this is something that may have missed you if it is that you the origin, that point over there is the point 0 on the x, 0 on the y. That's called the origin. So that's the point 0, 0, right? So that's something that is that's something that's important to note. Here we go again. Is we are going to draw a line given an equation. So some questions will give you an equation, and from this equation you have to draw what the line looks like. Yeah. So the first thing that we need is we need 2 points. So we could literally choose any 2 points that we want, and I'll show you why just now, right? But we can literally choose any 2 points that we want. So let's start off with the first point when x equals 1, right? So when x equals 1, this implies that y is equal to 2, and I'll take this 1 and I'll put it wherever x is. So that's 2 multiplied by x, which is 1. And then plus 3, right? So 2 times 1 is 2 plus 3 is 5. So therefore, when x is 1, y is equal to 5, and I have my first point. Yeah. So I could draw that point here when x is 1, y is 5. So that point is over there, right? So this is the first point. Now let's go for a second point. And the second point is when x equals, let me try 7. No, let me try 6. When x equals 6. This implies that y is 2x plus 3. Right? So 6 2s are 12 plus 3, which is 15, is it? Therefore, the second point when x is 6, y is 15. So therefore my 2 points are 1, 5 and 6, 15. Right? So I already plotted 1, 5. Let me plot 6, 15. And now what we do is we join those 2 points with a continuous line straight across. And that is the only problem I have with this software, is that it don't really have anything. Insert line. Let me see if I could draw a line. No, I can't. I know what to do. Insert line. There. Something like that. Yeah. Now you see how I drawing the line straight across, and the line is joining the 2 points, and I'm gonna try to get the line to join those 2 points as exactly as I can. Alright, and so that is your line. The line y is equal to 2x plus 3, and you could see a way to notice something, right? And Shazay was asking this question last class. You see how I use 2 points, and I literally pull those 2 points out of a hat. I say when x is 1, and I notice that everything is positive, so I stick with positive. You know, I could have choose negative, but why would you do something like that? Yeah. And the line goes straight across. So Shazay had asked, can you really choose any values for x? And if you look at it, the line goes straight. This is the line y is equal to 2x plus 3. The line goes straight across the graph to infinity. To infinity. So that means that any x value you choose, like we just say if we choose x is 4 and we go all the way up, we'll see that y is 11. So this is the point 4, 11. Right? So even to infinity, let's choose, well, you can see if I choose x is 12, that y value is gonna be out of my graph. So let's choose x is 2. When x is 2, we can see that y is 7. Yeah. So literally any x value you choose will have a corresponding y value, because this entire line goes straight to infinity in both directions. Yeah. And that is why you could just simply choose any x value that you want and get the corresponding y value, and you'll end up having your 2 points. Right? So Shazay, is this okay for you?
Yes, sir.
Right. So Scotia, this cool for you?
Yes, sir.
Alright. So you guys just take a little 5 minutes and write this down. Remember what I told you about your Cartesian equation, right? When you're drawing, you want to make sure that if you use 1 centimeter as 1 on the x-axis, you want to use 1 centimeter as 1 on the y-axis. So you want to be as equal as possible on both axes, right? So yeah, take 5 minutes, draw this, write down this. Now from now on, whenever we doing these questions, I would like you to make these statements here. Do it exactly how I did it in terms of writing down the statement. When x is 1, then you plug it into your equation. Then when x is 6, you plug it into your equation. You get both points, but then you state both points at the end. So it's a story that we're telling really. Yeah. So take 5 minutes, write this down, just say done it when you're finished. Later on we're gonna do how when they give you the line, you have to find out what the equation is. So we'll deal with that maybe later this class, right? But so far right now we're talking about how to draw a line when they give you the equation. So I have another equation here, and I'm gonna give you 5 minutes to see if you could draw this equation, right? So draw this equation, and I'll give you 5 minutes, and just let me know when you're done. So let's go with it, right? I'm just gonna choose any 2 points. You didn't have to choose the same points as me. You would have gotten the same line, right? So even though we're not choosing the same points, we are supposed to get the same line. So if yours looks different, then it's not correct, right? So let's go with when x equals 1. Therefore y is equal to 1 minus 5, which is -4. So the first point is 1, -4, right? So let's go with when x equals 6, right? Y is equal to x minus 5, which is 1. So therefore when x is 6, y is 1. So the 2 points are 1, -4, and 6, 1. Right? So let's plot these things here. I have 1, -4, which is here. So you notice I went on the x and I find 1. And anywhere on this vertical line there, x will be equal to 1. Okay. And I come down until I find -4 on the y, and that's the first point. And the second point is 6 on the x, 1 on the y. And now let's see if I could draw a line. And remember, the line that you draw is supposed to go straight through your graph, eh? Straight through the graph. And that is the line that you should have gotten. And that is the line y is equal to x minus 5. And I want you to notice something, right? We have the x, and then we have the number -5. And that -5 is where the line cuts the y-axis. You can see the line cuts the y-axis at -5. I want you to notice it here too, right? Over here we have +3, right? And notice that the line cuts the y-axis at +3. Yeah? So you want to make a little note of those things, a mental note. So did you guys get this line? Yeah?
Yes, sir.
How about you, Shazay?
Yes, sir.
Okay. Right? Yeah, I'm sure you didn't choose the same points I did.
No.
What was the points?
No.
What was the points you chose? Give me your first x point, Shazay. Your first x that you chose.
The first x was 3.
All right. So don't tell me nothing more. If your first x was 3, then your y is supposed to be -2.
Yes, sir.
All right. And where's the next x you chose?
The next x was 1.
So yeah, 1 and -4.
-4.
What about
yeah.
you? What about you, Scotia? What was the first x you chose?
I have the same exact points. 1 and 3.
All right, that's interesting. But you saw here, Shazay, that even though we use different points, all of your points are still on this line. All of Scotia's points are still on this line. All of my points are still on this line, right? So we can literally choose every point. Now, 5 minutes, draw this one. Be careful though, you're still choosing positive values of x if you want, but once you plug in a positive value of x in there, it's going to become negative, right? So just write out your statements very, very clearly, and you should be okay. All right. So I'm just gonna choose any 2 points when x is equal to 1. All right. That means that y is equal to minus whatever x is, minus 2. So minus 1 minus 2 is minus 3. Yeah. So the first point when x is 1, y is negative 3. And let's choose when x equals. Let's get a little bold. When x equals negative 4. Yeah. So y equals minus whatever x is, minus 2. So that is a negative of a negative is a positive, so that's 4 minus 2, which is 2. So therefore when x is negative 4, y is positive 2. So I have my 2 points. 1, negative 3, negative 4, positive 2. So let's go with 1, negative 3 is about 2. And then negative 4 on this side, but positive 2 up here. And now we'll have a line that might be looking something like this. Hey, penance for you. Penance for you. You gonna have to write I must not be late 100 times. You cool with that? Nope. Alright. So notice something again here. If this is what your line looking like, notice how this number here is negative 2, the number after x. And notice how the line cuts the y-axis at negative 2. I just want you guys to notice that, right? I want you all to notice another thing, yeah? And we spoke about this in the last class, right? Notice how the numbers in front of x here was positive, and so the line ended up sloped this way, yeah? The number in front of x here was positive, right? The number in front of x here is 1, and that's positive, so the line sloping this way. But in this case, the number is negative 1, and so now the line slopes this way. So we have some clues here when it comes to the equation of a line, right? One of the clues, and we'll write down these clues a little later in class, but one of the clues is that this number tells us where it is going to cut my y-axis. And then the sign in front of x tells us which direction it's going to be sloping in. Yeah? So once you know these things, you could just literally look at an equation and just kind of figure out what it's going to look like before you even do any of your work here. Look at the sign in front of x, you'll get a figure as to how it's sloping, and then the number after tells you where it cuts your y-axis, right? I have another one here. Let's just do this one for the last one, and then we'll just move on to some new stuff, right? So this is the last one here. Take 5 minutes with it, and then we will talk some new talk, and of course Caitlin will get to do this one too. And Caitlin, we were talking about these statements here. When you're given an equation, you want to say, well, when x is 1, you plug x into the equation and you get y is equal to something. And that is your first point. When x is whatever, you plug it into the equation, you get y is something, and that is your second point. You okay with that, Caitlin?
Yeah.
Alright, okay, cool. So let's see how are you doing with this, Caitlin. So you'll have 5 minutes. Remember, and this one is for Caitlin too, that when you are drawing your grid, your axes, if you use 1 centimeter to represent 1 unit on the x, you'll want to use the same 1 centimeter to represent 1 unit on the y, and that is just to ensure that your graph will come out nice and even on both axes and it wouldn't be slanted one-sided kind of thing, right? So yeah, 5 minutes. Okay, so I am just going to choose any 2 values of x. So let's choose when x is equal to -3, right? So that way y is equal to -3 times -3 plus 2. Y is equal to 3 3s are 9, positive 9, plus 2, which is 11. So the first point is -3, 11. The second point, when x is equal to let's choose 4, positive 4. So therefore y is equal to -3 times positive 4 plus 2. Just 4 3s are -12 plus 2, which is -10. So now I have this other point, 4, -10. So I have my 2 points here, -3, positive 11 is all the way up here. Right? And then I have positive 4 and -10. I wonder if I could even join those two. Positive 4, -10 is all the way down here. So let's see if I could join these two now. I'll insert a line. That's not quite it. Right. So we could see here again that this is what the line looks like. We could see here that it has a negative in front of the x, so it's sloped that way. We call this a negative gradient, but we'll see that just now. We'll see here that it have a positive 2 here, and so the line cuts the y-axis at positive 2 there. Now, just out of curiosity, Shazay, what are the x value, the first x value that you choose?
I had 3.
X is 3, so when x is 3, you get -7 for y?
Yes, sir.
Alright, so there it is, x is 3, -7. Caitlin, give me the first x value that you choose.
I had x was 1.
X is 1, and when x is 1, we get y is -1?
Yeah.
Alright, so good. And Scotia, give me a point, that 1 x value.
I had x was 1.
X is 1. You had anything else? What's the next one?
The next one was 4.
Okay. Oh, 4, well, which is what I had, so you got -10, right?
Yeah.
Okay, nice. So I hope everybody had things that looked like this, right? So we could see here from these questions that this is how to draw a line when you are given the equation. So when you're given the equation, you can literally choose any two x values and find y values. You find 2 points and then you draw your line. Now we have other types of lines that we had to talk about, and I know that I gave you guys this assignment. Did anybody actually do this assignment?
I try it. This is sure.
Alright, would you guys like me to do it now real quick to show you?
Yeah.
Alright, so let's just get 2 points, and I wouldn't make all of the statements and things, even though that is kind of bad teaching, but I'll just doing it real quick, right? So like when x is for this line here, when x is 1, y is gonna be 1 plus 2, which is 3, right? And then when x is, let me just say 4, y is gonna be 6. So I have my 2 points there, 1, 3, 4, 6. So let me plug them in. 1, 3, 4, 6. So let me see if I could draw in that line. I'll use blue for that one. And you can see here the same thing I'm talking about. We have a positive x, so it's sloped that way. And we have positive 2, so it cuts the y-axis at positive 2. Yeah. Now let's do the second one. The second one, and let's label the line y is equal to x plus 2. Right. Now let's do the other one in a different color. So this one here. So let's choose when x is 2. When x is 2, 2 minus 2 is 0. So we see y is 0. How do we plot 0 on the y? Let's see. And let's choose another one here. When x is 0. Let's choose when x is 0. We could see that 0 minus 2. When x is 0, y will be negative 2. So let's plot these two very curious points and see how we get. Right? When x is 0, x is 2, so I'm gonna go 2 on the x, 0 on the y. So where am I going to move? I'm not going to move anywhere. If I move here, I'm gonna go to 1. If I move down, I'm going to go to negative 1. So I am actually already on 0 on the y here. Right? So this here, 0 on the y, you can see that's on the x-axis. The x-axis itself is put at 0 on the y, and that is where they both cross, right? So that is the point there. And then the next line is when x is 0. So you know x is 4, 3, 2, 1, 0. Y is negative 1, negative 2, so it's down here. So when x is 0, y will be on the y-axis, because the y-axis is located where x is 0. So now I have this line here, and let me just insert a line like this. And that is pretty much. So Shazay, did you get your two lines to look kind of like this?
Yes.
Alright, now let's check. Now you could tell that these two had positive gradients, right? And these two are going to have negative gradients, so they're going to be sloped the other way. One is going to be cutting at positive 2, the other is going to be cutting at negative 2. So let's check these guys out. I'll draw this one in red. So this one here, right? Let's find the 2 points first, right? When x is positive 1, so I'm going to put positive 1 there. What will y be? Y will be, well, that positive 1 becomes negative. So that is minus 1 plus 2 is 2 minus 1, which is 1. So we had the point 1, 1, positive, right? Let's choose when x is 5. So when x is positive 5, right? I'm putting that into the equation. Somebody had a mic on, right? When x is positive 5, I'm putting that in the equation. So now the negative makes it negative 5 plus 2, which is negative 3 we get for y. So my 2 points here will be when x is 1, y is 1. And when x is 5, y is negative 3. So that will be around there. And so now this line will look like this. Oh, and I didn't label. So let me label the green line. Y is equal to positive x, so it have a positive slope, minus 2, so it cut in at that negative 2 point there, right? And then the red one is y is equal to negative x, so it have a negative slope, plus 2, so it cut in, you can see, at positive 2 over here. Right? And now let's do the last one. I'll do the last one in black. And this last one is negative x minus 2. So we can see here that it have a negative gradient. So let's say when x is positive 2. So when x is positive 2, that'll be, the negative will make it minus. So I taken x as positive 2, and I don't want Caitlin to confuse this. Yes, I am taking x as positive 2, but then when I put it in the equation, minus x, so the equation makes it negative. But you notice the point here is positive because I took x to be positive 2, right? So don't get confused too much. So negative 2 minus 2 is negative 4, right? And now let's choose x to be a negative number. Let's choose x to be negative 1. Alright? So because I'm choosing x to be negative 1, I'm putting that in the equation. So minus negative 1 is positive 1, minus 2, which is negative 1 again. And 1 minus 2 is minus 1. So now I have these 2 points here. The point 2, negative 4, and then the point negative 1, negative 1. Right. And now I will try to insert a line here. And that is what you should have gotten. This here is the line y is equal to negative x. You can see it have a negative gradient. It's sloping that way. Minus 2, you can see that it cut in at negative 2 here. And you can see that we kind of have an X-Men symbol going on here. Right? So, so is this close to what you guys got? Okay, guys, so moving on now. Right? What we just did was we were able to draw a line given the equation. So they give you the equation of the line, and you find 2 points on that using the equation. You find 2 points and you draw your line, and boom, we nice and easy. Now next up, we have a couple more different types of lines to take a look at here. So this first kind of line is called the horizontal line. And a way to take a look at this line here, we have this horizontal line going straight across, And then I put some points on this horizontal line here, and you can see we have some points on the line here. And if we look at the coordinates of these points that are on this horizontal line, we could see that, okay, so this first point is, this first point over here is 5 on the x and 3 on the y, so 5, 3. This next point is 3 on the x and 3 on the y, so 3, 3. This next point here is 0 on the x, right? And then 3 on the y, so 0, 3. This next point here is -2 on the x, but 3 on the y. This next point here is -4 on the x, but guess what? 3 on the y. So we have all of these points on the line. What do you guys notice about all of these points?
They have the same x value, not y value.
They all have the same y value. Y is always 3. So you can see that when you draw a horizontal line, the y value for that horizontal line will be at a certain level on the y-axis, and just like how the x-axis is at the level of 0 in terms of the y-axis. The x-axis cuts the y-axis at the point 0. So this line here cuts the y-axis at 3. And because it's a horizontal line, means that y will always be equal to 3. So therefore the equation of a horizontal line is just simply y is equal to 3. Right? Now notice there is no x in here. Yeah? So you could say here that remember how when x positive, the gradient is so. When x negative, the gradient is so. But when x is positive, like y is equal to x plus 1, that is because I have a positive 1 over here. So you get a gradient of positive 1. Or negative 1, you get a gradient of negative 1. But when you have a horizontal line has no gradient. It's flat. Yeah? So because it's flat, we could say that the number in front of x is actually 0. The gradient is 0, so therefore it has no x. That x gone, you just end up with y is equal to whatever number that the line is. Right? So when it's dealing with a horizontal line, and this is it, students get messed up with this because they will see a horizontal line, and because they know the x-axis is horizontal, they will call this x equals 3. But no, you could see here that the x values are always changing. Yeah? Is the y value staying the same? So this is the line, y is equal to 3, right? So the equation of this horizontal line is y is equal to 3. So I'm gonna give you guys 5 minutes to see if you could just write this down, and the header for this is horizontal lines. Look it over here, right? So horizontal lines, 5 minutes. Just give this a quick sketch and say done it when you're done. So we're talking about a horizontal line, and we see here that a horizontal line have an equation y is equal to 3. Anybody think they can give me an example of an equation of a vertical line? Like, let me just say, if I was to draw this vertical line here, anybody think they could tell me what's the equation of that line?
X equals to 2.
Yes, x equals to 2. Very, very good. And let's just check it out right here, right? So now we're dealing with vertical lines. And you see we have a vertical line and we have different points. And just the same thing, if we write out these points, we'll see this point here is 2, -5. We'll see this point here is 2, -3. We'll see this point here is 2, 0. We'll see this point here is 2, 3. And this point here is 2, 5. So you can see that the line is vertical. The y values are always changing, right? But the vertical line, yeah, the x values stay the same because it always at one x level. X is always 2 on this vertical line here. So this equation of this line is x equals 2. Notice there is no gradient, and I want to talk about this after. There is no y. The gradient of a vertical line is said to be infinity. Right? I want you to think about how could that be infinity? Yeah, the gradient of a vertical line, because we have here x is equal to 2. It don't have no y. Yeah. So think about it. So 5 minutes to write this down. Vertical lines. So we were talking about horizontal lines. We were talking about equations of lines, and we saw that equations of lines just tell us certain things. It just tell us things about gradients. It just tell us things about where it cut in the y-axis. We could use it to find 2 points to draw the line. Then we saw some special types of lines here. We have horizontal lines, which will always have the same y value, right? We have vertical lines where always have the same x value. Yeah. And now let's talk about ranges. And you can check this out. Remember when we have the equation of a line, right? Whether it's x is equal to 2 or whether it is one of these. When we have an equation of a line, we usually draw the line straight across the graph paper. And this is to imply that this line goes straight through infinity, right? So straight to infinity is where this line goes, yeah? So this line is longer than your graph paper could ever be. So it goes straight through the graph paper. But what if we don't want it to, right? What if we want to just draw a short line? So we could use ranges. Right? So instead of drawing an infinitely long line, we could set a range for our lines. For example, this is the line, this is the line y is equal to 3. But look at the range. We have a range here of x values less than 2 or greater than -4. So you can see here that we have x is 2 here. We have x is -4 here. So for this line, we only want x values that are greater than -4, and we only want x values that are less than 2. So you can see here that the line only stops at 2. It doesn't go more than 2. The line stops at -4. It doesn't go less than -4. The line must be greater than -4 and it must be less than 2, right? So so everybody understand how to set a range for your lines? Shazay, you okay with this?
Just explain that one more time.
Alright, no problem, right? So you can see here that if I wanted to draw the line y is equal to 3, I know that that's a horizontal line cutting at 3. So I would usually draw an infinitely long line. Yeah, that line stretching to infinity. But I don't want that. I want to just draw this line here. If we look at this line, this is the line y is equal to 3. It doesn't really matter what kind of equation it is, right? We could just set a range using the x values. So we could say I only want this line when x is less than 2 or when x is greater than 4. So x had to be between negative 4. X had to be between negative 4 and 2. So look, I have negative 4 here, and look, I have 2 here. And the line will only exist between negative 4 and 2. So the line is greater than negative 4 coming up this way, but it is less than 2, so it doesn't get more than 2. So now I could specify this range here. It's also called a domain, but we could see the difference between a range and a domain when we do functions and relations, right? But we're just using the word ranges for now. Yeah. So we're using this range of x values here and saying, hey, this line will only exist within this range, and this is the line that we get. Yeah, how you feel about it? 2 minutes, say done it when you write it down. Remember, you could sketch this. You don't have to, you don't have to graph it. I don't want to confuse anybody, so let me know if this is confusing to you, right? But it's just a cool little thing that I want to point out, right? And Shazay, let me know if this confusing you. I really don't want to, right? But you see how this line here is the line y is equal to 3 because it passing through the tree on the y-axis. You all understand that, right?
Yeah.
Right. Now, if I was to draw this line here passing through 2, this would be the line y is equal to 2. You agree with that, Shazay?
Yes, sir.
And if I was to draw this line passing through 1, this would be the line y is equal to 1, yeah?
Yes, sir.
So therefore, if I was to draw this line passing through 0, this could also be seen as the line y is equal to 0. Make sense?
Yes, sir.
So the x-axis, the equation of the x-axis is the line y is equal to 0. Yeah? So that is a nice little point. Just make a little note of that. Go back to your horizontal lines and make a little note of that. The equation of the x-axis itself is the line y is equal to 0. Similarly, if we see here that when we draw a vertical line cutting the x-axis at 2, that vertical line is x equals 2. And if I draw a vertical line cutting the x-axis at 1, that vertical line is x equals 1. So if I was to draw a vertical line cutting the x-axis at 0, that vertical line will be the line x is equal to 0. So for vertical lines, you could just write a note that the y-axis, the equation of the y-axis is actually x equals to 0. And simply put, any point on the y-axis, you can see where's this point. This is the point 0, 1. This is the point 0, 2. This is the point 0, 3. This is the point 0, 4. So any point that is on the y-axis will have an x value of 0. Right? So a nice little note to make here that the equation of the y-axis itself is x is equal to 0. I confuse anybody with that?
No, sir.
Caitlin,
Yes, sir.
how are you feeling about this, Caitlin? You okay?
Yeah.
You sure you have any questions about anything?
Yeah, I did.
Alright. Now we were talking about ranges, and you can see that I set a range using my x values. So I say, well, alright, the range x is greater than -4. but then x is less than 2. So I'm basically staying inside of this range over here. I'm not going outside of that range at all, right? Now, you could use your x values to set a range for any equation. So if I had this line here, and this is the line y is equal to x, right? That's the equation of this line, y is equal to x. I could set a range. I could just say, all right, let's do a range of y is equal to x, but I want x to be up to 5, not greater than 5. So x can be less than 5, but it's going to be greater than -2. Right? So we can see here that I draw the infinity line, yes, but now I'll go look at the range. The range is from 5, which is here, to -2, which is here. So now I could draw the line within that range from here to here, and it's within the range. X is 5 and x is -2. So therefore you don't have to draw a full infinite line. You could just draw the line within that range. So the point that I'm making here is that you could use your x values to make a range for almost any line. But you can't use your x values. Well, you can see here again, this is the line y is equal to 2x. So the line y is equal to 2x, and we have a range -2 to 2. So x has to be less than 2, right? And x has to be greater than -2. So you can see here that the line will go from here to here. You understand that, Shizzy?
Yes, sir.
Yeah. If we extend the line more, you see that the line will start to go greater. You'll get x values greater than 2. We don't want that. Right? So you're okay with this, Shizzy, right?
Yes, sir.
Right. Now, basically for almost any line you could use your x values, but for vertical lines obviously you can't use your x values, right? So I can't set a range, let me just say, for x to be, like let me just say x is less than 4 or greater than -1. X is less than 4, greater than -1 in this range here. But guess what? That vertical line is never ever going to cross that range. You can see why. This vertical line is only going to go up and down. Yeah. So for vertical lines, right, you cannot use the x values as a range. Obviously, you had to use your y values. So you can see for this vertical line, x is equal to 2. But the range of it is stated in terms of y. From y is 3, right? So y cannot be greater than 3. So y is less than 3, but y is greater than -3, right? So for all other types of lines, you could use your x value. But once the lines is a vertical line, you should use the y to be your domain. Now, this is not something you have to bust your head with for CSEC. You don't have to bust your head too hard over this stuff for CSEC, because I never really saw CSEC bring this in a coordinate geometry question. However, still understand it, because you will get something like this in inequalities question, which is something we'll do soon. You will get something like this for other types of questions, inequalities, or what else you'll get at range thing for. You could even get it for statistics. We see it here. We see the range thing in sets. So the range thing is something that we've seen already, has set in a range for values. We've seen it already. Yeah? So it's really important that you understand. Now, I've never seen a range, they're asking you for a range for a coordinate geometry question, really. But I mean, it is on the syllabus. You do need to know it. You do need to understand it. And it is applicable in other topics that we are going to do in the very near future, right? So everybody understands horizontal lines, vertical lines, and ranges, right? The two assignments both have equations. You can see here that some of the equations here are for vertical lines, some of the equations are for horizontal lines, and some of the equations are for normal lines that have gradients. And then each one of the equations has a range, right? So I can't remember, if you draw this, it have a picture that will emerge. I think one of them is a house. One of them is supposed to look like this. One of them is supposed to look like this, or something like that. I can't remember, right? And then the other one, I can't remember what this one's supposed to look like. What was this, boy? It was a picture. It's some picture, right? So, I mean, do you guys want to do both of them, or do you guys just want to do one of them? We still have some time for the class. So this second one you'll do for homework. This first one you'll do now. How you feel about that? Oh, I could sense your excitement. Yes, I could really sense your excitement. So I'm gonna give you 15 minutes to see if you could tackle this question. And there is a hidden picture. I can't remember if this one is the house or if this one is the house. And I can't remember what the other one is. But there is a hidden picture. So see if you could draw these lines right now. You have 15 minutes and I'll see if you guys could tell me what the hidden picture is. And remember, if for vertical and horizontal lines, for these lines here, right? All of these lines that I mark off are vertical and horizontal lines. You could see here that for vertical and horizontal lines, you don't have to go and find 2 points. Yeah, because you know what the line is. The line just gonna be vertical or horizontal, cutting at x is 3 or y is 2 or whatever. So it's only for these guys here that you had to go and find 2 points, right? When you're drawing the line, yeah, you had to go and find 2 points for these guys here. And remember, when you're doing that, you want to make sure you have the proper statements as well. So 15 minutes, and you'll tell me what picture you got.
Same.
And what image you got?
I get what looks like a house.
All right. It might have something off because I think I get one number in the ranges.
Yeah. And I think is x is equal to 1. And y is between 0 and 3.
Oh yes, it could be 0 and 3. Yes. So
I think that's like the doorway or something.
Yes. All right. So let me see. And if my boy, you see when people start to correct me, that is how I know you understand it. Yeah. So I'm real happy to see that, right? Right, so let me take a look at this. So alright, so first I have the line x is equal to 3. So we know the line x is equal to 3 is a vertical line passing through 3. But this one has a range of 0 to 3. So 0 to 3 gonna take us till about here. Alright? 0 to 3 gonna take us about here. So here. And I'm not going to use a ruler, so my line is going to be a little bit messy, right? So this is the line x is equal to 3 between 0 and 3, right? Now let's take a look at the next line. X is equal to negative 3 between 0 and 3. So we come in on this side now. Negative 3 is a vertical line between 0 and 3, so that is this line, right? And now we have, well, we're gonna do these two hard ones last, right? So now we have the line x is equal to 1 and negative 1, right? No, it's not 3. Is this one supposed to be 2? That is what it was. This one's supposed to be 2, I think. Let's not mistake. Yes,
Yeah.
that one's supposed to be 2. Yes, right. So x is equal to 1. So that is this line, a vertical line here between 0 and 2. 0 and 2 is there. 0 to 2, right? And that is the vertical line x is equal to 1. And now we have the vertical line x is equal to negative 1, which is on this side between 0 and 2, which is this, right? And now we have the line y is equal to 2. We know that's a horizontal line. So y is equal to 2 is right here, right? It's supposed to go all the way across, but we have a range with it, and the range is between negative 1 and 1. So between negative 1, from this is negative 1 and this is 1 here. So we have that line y is equal to 2. So let me just write in these line names. This is the line x is equal to 3. This is the vertical line x is negative 3. This is the line x is equal to 1. X is negative 1. This is the line y is equal to 2. And now let's get to these guys here. Okay? So we have the line y is equal to negative x plus 6. I'm not going to do the statements just for the sake of time. I'm just going to write it real quick. Let's just see if x is 1, what is y going to be? So if x is 1, minus 1 plus 6, so y is going to be 5. What the hell is that? No. So y is going to be 5, positive 5. And let's just see when x is, I chose when x is 1, 5. And let's just see when x is 5, right? When x is 5, then negative 5 plus 6 is positive 1. So I have 5 and 1, 1 and 5. So let me plot these two lines, these 2 points here now. The point positive 1 and positive 5. And then we have the point negative 5, no, positive 5 and 1. So we could see the line going so, right? And we could tell the line would do that because it have a negative gradient, right? So so we could draw the line straight across like that, but the line does have a range. And where's the range of this line? Between 0 and 3. So between 0 is here and 3 is here. So that means that the line, so let me just draw the full line first. I'll just draw the full line, insert a line. And the full line looks like this. But we don't want all that. We just want a range, and the range that we want is 0 to 3. So this is x is 0 from here, and this is x is 3 over here. So from 0 to 3. So that is, this part of the line is what we want, from here to here. Yeah? And then now let's draw the other line, x plus 6. Y is equal to x plus 6. Now let's use the range, because we can see the range here. X is between negative 3 and x is 0. So let's try when x is 0. When x is 0, right, y is 6. You can see that quite easily, right? So when x is 0, y is 6. So that is over here, right? And then we could try the other one when x is -3. So when x is -3, y is what? -3 plus 6 is +3, right? So when x is -3, y is +3, so that'll be here. So now this is the second line. And look what we have, ladies and gentlemen. We have a nice little house. We just draw a little house and it looks really, really cool. I wish it had a chimney and a window, right? If you want to put a chimney and a window, you could probably put here and then a line, and you could figure out what the equations for these lines are. Yeah, and you could probably put a window here, and these will be 4 lines if you put a window there, right? But essentially, this is what we got. Scotia, you got anything looking like that?
Yes, sir.
Right, and Shazay, you got this too, right?
Yes, sir.
Beautiful. All right, good. So this is coordinate geometry, the introduction to coordinate geometry. So your assignment for Tuesday is to do this one, and you see here that you have to draw is 4 images, right? But you have to draw them on the same plane to discover a picture. And I can't remember what this one is, right? I cannot remember what this one is. But what we've been doing is we have been drawing a line given an equation. So they give you an equation. What do we want to do? We want to get 2 points from the equation, and then we could draw the line. Right? But in the next class, we're going to be going in the other direction. In the next class, they're going to give you the line. And then from the line, you're going to have to find the 2 points. So you could just look at any 2 points on the line, get the coordinates for it. And once you get the coordinates for the 2 points, then we will find the equation of the line. Yeah? So today we did this one, where you're given the equation, you find your points, you draw your line. Next week on Tuesday, we're going to do this one, where you're given the line, you find your points, and then you work out what the equation of that line is. Right? So you can see what we did today is we used the equation. Given an equation, we draw the line. We saw that it had a couple of special types of lines we had to learn about, namely horizontal and vertical lines. We saw that we have ranges that we could deal with when we're doing these things. And remember the beginning of the last class, we were seeing, the Superman symbol and the Batman symbol, and we were seeing that all of these things have equations. Well, look at that. This here is the equations for a house. And this is how a house does look like in algebra. This is what it looks like as a picture, and this is what it looks like as an equation. So now you could literally try to draw, and we'll see if you could figure out what this image is going to be, right? And then next class is where we'll take a look at this, and we will talk about these kind of things. We will talk about these types of equations, which are a little more common in terms of coordinate geometry. So next class is quite important, and at the end of the next class we'll be doing some you can see here, this is a typical CSEC question where they actually draw the line. They give you the line on a graph, and they're telling you here, find the gradient of the line and then find the equation of the line. Yeah, so yes, that is what we're gonna be doing next week, right? So we have hopefully we could finish all of this on Tuesday.